Okay, oops, I accidentally ended the recording early. Let's try that again. So, I have an idea of how this works, but let's say the gases 2 and 3, and this is because you're going to have leftover gas anyways. Okay, so let's think about it. Is a positive, you need to ensure that it's always a positive value. Otherwise, it's going to be and the addition is always going to be what's the addition gonna look like? I guess let's just start off with a naive solution and see if it works first. So just do gas equals to 0 for now, and then you do for I. So this is going to be the starting gas. Maybe something will help is calculating the difference between each array. So that's how much fuel you have minus and then the positive Because if, let's say, this is 3, 2, and this is, let's say, 1, 2, and you start off at position, so the difference array in this case would be 1, 1, which means that 1 over here, which means that after you make this journey, from gas station 0 to gas station 1, here you have plus 2 gas, and then along this journey you minus 1 gas, so here you still have a plus 1 gas bonus. So I have this, I have this, 1 and 1. Okay, so I can't really spot a pattern yet for that. Let's try something like this. 1, 2, 3, 4, 5, 3, 4, 5, 1, 2, like this. The difference array is going to be gas, cost, difference, this is going to be -2, this one's going to be 3, this one's going to be 3. Okay. More or less roughly lined up. So the idea is if I start off at 3, okay, so it tells us we can return to station 3. So here, so at the start of index 0, I'd have 6 bars of fuel because 9 minus 3 is 6. I have 4 extra bars of fuel here. Here I have 2 extra bars of fuel. Minus, and then here. Okay, so wait, hold on. Do I just add the difference array and then just see if it equals to 0 then? Okay, I guess maybe that's it then. I just add it and see if it equals to 0. But then the question becomes, well, where do I add it from so that it, well, does equal to 0? Because I can very well imagine, let's just try with 2, 3, 4 in this case. 2, 3, 4, 2, 4, 3. Difference is going to be -1, -1, and 1. Okay, so our new problem, I guess. that's the new question. Is there an index I can start adding from such that the running sum is always greater than or equal to 0? I got the idea now. I just need to make some space over here. Difference is over here. How can I develop an algorithm for looping through this difference array so that I know that there is a position where I know I'm gonna have to loop through the array at least once just to check every number. So I can just do for. So if I do a for loop this, find the first one that's positive. So in order for the running sum to always be positive, then the how do I know, well, which, okay, whatever, let's just do a slow solution, see below. This I is going to represent the starting, and if no, because every time we reach a positive number, I'm going to have to, like, let's say, what if the loop was like this? Then I'd have to loop through everything, which is like O of n squared. Is there a way I can just loop through it once to check if it's possible? If there exists a solution, it's guaranteed to be unique. Because the thing I'm scared about is, what if the difference array looks like -3 and then like 3 or something, yeah. Like this, for example, because if you start at 4, you have 4 to this one works, you'll be able to make it. But then, for example, if you start at, oh, that's not what I want. For example, this is where you need to start at, but then for the algorithm, if you start it over here, then that's a bit problematic. So how can I figure this out? Oops. And then like another example would be, say, this was just a really massive number, but then over here, this is a small number, and like if this was just a super large, here, how would I know that? Okay, maybe I got an idea. So what if I just combine any consecutive negatives together? So here, if I combine the consecutive negatives, this is going to become and this, if I can just bind the consecutive, that's just going to become 12, like this. Okay, maybe that works. It's like I just keep going until no, but if I combine them together, I'll lose information on the original indexes. So that doesn't work. What do I do then in this case? Maybe I'm just overcomplicating. I start at -2. So every current iteration, what can I keep track of, maybe? Because this is supposed to be circular. If it's circular, what are some properties of the circular that I can exploit to make this work? -3. It's the left and right of it, maybe? What if I just... I don't know how to make the... Okay, whatever. Let's just try and get the thing to work. So if I is greater than or equal to 0, so for the range here, is there an index I can start from such that the running sum is always greater than 0? How do I do this? How can I develop an algorithm for this? I don't... Surely there's an easy way. Well, I'm just super overthinking it. Like, let's say for this bottom case over here, how would I know which index to start from? I know that the starting index is always... Okay, so if I just shift the array then, five goes out at front. This. Oh, I don't know. I really want to do this though. Like over here, this one is just super complicated because there's gonna be plenty. And for something like this is it's like positive, negative, alternating. And what if it was something like this? Like in this case, any of these could be valid, but like it's a unique solution, so. If there's only one possible solution, well, how can we know that there's going to be only one solution? It's possible that okay, maybe it's a cumulative sum thing. I think let's explore what happens with a cumulative sum. This one doesn't work. So -1, -1, -1. That one doesn't work either. Let's just try and concoct. Start up at 5, so I'll have 1 left over 8, 7. If sum looks like this, so based off of this, then is it possible for me to tell where to start from? I'm not sure. Let's just do the naive solution then, I guess. For I in range I plus 1 plus length, so we're going to loop from this index -9 like that. Okay, let's just try and work on getting a solution first. And then we need to make sure that it's I plus 1 again, because we need to loop through everything. After the for loop, we break out of the for loop. So if it ever falls below 0 at some point, break out the loop and then we continue. See if this works. The answer should be unique. Oh, oops. You're right. I guess you can do negative indexing, you can't do positives. Time exceeded. Yeah, that makes sense. I expected it to exceed, but really? Okay, let's look at the solutions. O of one space. How can I... What? Sign in? Okay, I'll deal with that later. I'll leave it at here.